Well, now we are going to see how total revenue, average revenue and marginal revenue curves appear in figure. Here is a recap of the previous slide. If we are given the demand equation, we can easily derive the total revenue, average revenue and marginal revenue equation. Changing sides of the variables, here we get P equals 50 minus 2Q, which is the average revenue. Multiplying price by quantity, we get total revenue, which is equal to 50Q minus 2Q square. And finally, differentiating total revenue with respect to quantities sold, we get the marginal revenue, which is 50 minus 4Q. The total revenue, average revenue and marginal revenue curves differ from perfect competition to imperfect competition. I have a video in which I have shown how they differ from perfect competition to imperfect competition. The link is given in the description from which you can follow. Here we shall focus on the graphical presentation of total revenue, average revenue and marginal revenue curves under imperfect competition. We shall use two panels. In the upper panel, we shall show total revenue. And in the lower panel, we shall show average revenue and marginal revenue. As we know, average revenue equals price. In the lower panel, we shall show price as well. The total revenue curve under imperfect competition is reverse U-shaped or concave as shown in figure. It means total revenue initially rises with quantity sold, reaches to maximum and then falls. Total revenue is maximum at Q1 amount of output sold and it reaches to zero at Q2 amount of output sold. This Q2 is double of Q1. For example, if Q1 is 10, Q2 equals 20. If Q1 equals 5, Q2 equals 10. In other words, you can say Q1 is half of Q2. For example, if Q2 is 50, Q1 equals 50 by 2 equals 25. Let us show this Q1 and Q2 amount of output sold in the lower panel of the figure. Here you see Q1 is halfway of Q2. Now we can draw the average revenue curve. To draw the average revenue curve, let us first consider a positive intercept. Here it is 50. Mathematically, it is the intercept of the average revenue curve. You see, in the average revenue curve, it is 50. Now we can draw the average revenue curve. It starts from 50 and ends at Q2, where average revenue reaches to 0. This average revenue curve is also the demand curve and we call it the price line. As we know, average revenue equals price. The marginal revenue curve starts with the same intercept, that is 50. You see, the intercept in the marginal revenue equation is 50. Hence, marginal revenue starts from 50 and passes through Q1. At Q1, marginal revenue equals 0. I repeat, marginal revenue starts with the same intercept, 50, and passes through Q1. At Q1, marginal revenue equals 0. Now you see, at Q1, where marginal revenue is 0, total revenue is maximum. At Q1, where marginal revenue is 0, total revenue is maximum. We can use it as the condition for total revenue maximization. So, the condition for total revenue maximization is marginal revenue equals 0. This is an additional condition, demand will be unitary elastic. I shall explain it just after a few seconds. Now let us return to the graph. In figure, Q1 is half of Q2. Now, if we move vertically from Q1 to the demand curve, we reach to C. As Q1 is the midpoint of this triangle, C will also be the midpoint on the demand curve. And at C, that is at the midpoint of the demand curve, demand is unitary elastic. Therefore, we can say at Q1 where marginal revenue equals 0, demand is unitary elastic, which we can use as a condition for unitary elastic demand. We can say demand is unitary elastic when marginal revenue equals 0. That is why in the condition of total revenue maximization, we add the additional condition unitary elastic demand along with marginal revenue equals 0. The price associated with unitary elastic demand is P1. It is called unitary elastic price and the quantity Q1 is unitary elastic quantity.